Good morning. My name is Avdhut Nilkant Deshpande. I am delivering lectures in Rugved Academy for higher secondary level, that is 11th, 12th chemistry. Today we are going to learn types of solutions. Now, but before we go to the types of solution, there are various things we should know it. First one, that is, what is solution? Second, what is solute? Third, what is solvent? These are the three things we must know before we know any other about it. So, what is solution? Solution, broadly we can say, solution is a mixture of solute and solvent. Now, let us see about what is solute and solvent. Solute, that it is a substance which get dissolved, and solvent is the substance in which other substance get dissolved. This is a very broad definition of this all three. Now we will see a detailed definition of each of them. First one, we will see about the solution. As I said, solution is a mixture of solute and solvent. So on this basis, there are again three types of solutions, and we will define each type of solution separately. First one, that is true solution, turbid solution, and third, the colloidal solution. Now, when we say there are three types: true solution, turbid solution, and the colloidal solution. It is based on the particle size of a solute. Now we will see that solute what it is and solvent again. But right now just bear with me. So this whole solution defined on the basis of the types of solute that we use. So basically first we say true solution. So what is true solution? True solution means it is a homogeneous mixture of solute and solvent, where there is no two distinct phase. So how we define solution? True solution is a homogeneous mixture of the solute and solvent. Now what do you mean homogeneous? Homo means similar. Genus means matter. When whole matter exists the same, then what we call as a true solution. For example, if you dissolve the sugar in water, suppose if you take the sugar in water, so this is water, and if you add the sugar in this, after stirring all completely, will we be able to understand which is solute and what is solvent? No. So it is a homogeneous thing, one matter. So that's something we call as a true solution. I mean, another example, lemon squash. Can you able to identify whether that is lemon juice is there and the sugar is there? No, we can't do that. It is same material, only one material in which we cannot distinguish which is lemon squash and which is sugar, that is which is liquid and which is solid. We cannot differentiate. So the true solution is that solution in which solute and solvent cannot be differentiated from each other. So that is something we call it as a true solution. Next, that turbid solution. What is a turbid solution? So turbid solution can be defined as it is a heterogeneous mixture. What do you mean hetero? Hetero means different. Genus means matter. When two different matter can be identified in that solution, that is called as a turbid solution. Example, simple, very simple. Take a glass of water, put the soil or clay in that. You can differentiate. Take another example. Take a glass of water, put oil in that. You can see the two different things, two different phases. So here we can, in this way we can also define the solution in this way also. It is the mixture of the solute and solvent when the two different phases cannot be distinguished from each other. That is called as a true solution. While in case of where the two different phases can be differentiated from each other, that is called as a turbid solution. So for example, as I say, we say the oil in water, we can differentiate. Oil being lighter than the water, so oil float and water we can separate from each other, which is not the case for the true solution. Even if you say another example, if you take add the water in milk, can you differentiate? It becomes same. So that is a true solution. Now the last, that is we are considering the quadratic solution. It lies between the true solution and the turbid solution. So right now in this chapter, we are not going to deal in detail about this. We are going to see this in a separate chapter in detail. So we are not going to consider right now we are going to deal with the quadratic solution because we have separate chapter on that. So now let us go to the next part, that is solute and solvent. Because while right now while we defining this the solutions, types of solution, we use many times the word solute, solvent, but let us know what is solute and what is solvent. See, basically it is solute means it is that part of the solution. It is that part of the solution which is in a small quantity. Okay, what is solute? It is that part of the solution which is in a small in quantity. And what is solvent? Solvent means it is that part of the solution which is in excess in quantity. Now this is very general definition. We are not talking in terms of chemistry. So let us talk in terms of chemistry. So what we say solute? Solute is that part of the system which is in discontinuous phase. Discontinuous phase means it is not completely occupied. So that is solute is in a discontinuous phase, while solvent, which is a continuous phase. Whole beaker is converted as a solvent, that is water, and in which we are going to dissolve the sugar. So sugar is a solute and water is a solvent. So these are the three basic definitions of the solution, solute and solvent. Now next thing is we have to furthermore differentiate that is within the solution, true solution also we have dilute solution and concentrated solution. Now, what do you mean by dilute? Dilute means it is that solution, it is in which the amount of solute is less as compared to the solvent. Say for example, 1 milligram of salt in 100 ml of water. So that is the dilute solution. Or 1 ml of hydrochloric acid dissolved in 100 ml of water. That is a dilute solution. Then next, concentrated solution. Concentrated solution means it is the solution in which the amount of solute is in excess or in a large quantity. For example, the concentrated hydrochloric acid, that is the amount of H plus ions are in the large amount. So that's why we have two types of solution, dilute solution and concentrated solution. So we say concentrated solution, that is in which the concentration of the solute is in large quantity. So that is called as a concentrated and this is a dilute solution. Now there is one more thing that we talk about, that is the saturated solution. How we define saturated solution? Now, how we define saturated solution? Now, let us take an example. Okay, again take one beaker of water, fill the water in this and add the sugar in this. So, we will stir it, get dissolved. Again, we add 1 spoon of water, 1 spoon of sugar, it will get dissolved. Again, we add. Now it will take time to dissolve. We have to heat it, but after heating, it get dissolved. So these are called unsaturated solution. But there will be a time. There will be a time at which no further solute can get dissolved in a solvent. That is called as a saturated solution. So what is saturated solution? It is the stage of the solution at which further addition of solute is not possible even we heat or boil the water, and that is called as a saturated solution. So we saw just now we saw the definition of true solution, turbid solution. True solution means what? Homogeneous mixture. Homo means similar, genus means matter, same matter. And second is what we can say as the turbid solution, that is a heterogeneous. Heterogeneous means two different matter can be separated. Oil and water or the sugar and water, they can be differentiated. And the now next we saw about the solutions, solute and solvent. That is solute in a small quantity, solvent in excess quantity, or solute in a discontinuous phase and the solvent is in a continuous phase. Then we talk about the saturated solution, that's where the further addition of solute is not possible. Further addition of solute is not possible. Even we heat that solution. And then that is called as a saturated solution. Now after learning all these things, let us see about the types of solution. Now there are various types, we will see one by one. The first thing, in which the solid is solute and solvent is liquid. Say for example seawater or if you add any sugar in water, where sugar is in small quantity and water in large quantity, so water is a liquid, that is solvent, and sugar is a solute there. Example is seawater. Example is seawater or sugar solution or salt solution. Then next state of solid, that is when the solute is solid and solvent is solid, both are solid. Then alloy, we have the various alloys. We can add the alnico, that is aluminium, nickel and cobalt, that is alnico. All the three different all three are the solids, they are get dissolved with it. Then iron and nickel, that also generate alloy, that is also the example of this, that is alloy. Then solid in gas. In case of solid in gas, the state of here the state of solid is solid and state of solvent is gas. That means here the solute is solid and solvent is gas, that is iodine in air. How can we say? I think for this you need to go in 9, 10, 10, even 8. Have you heard of the word sublimation? No? Okay. Sublimation, that is there are certain solids which never convert into liquid, they directly transfer into the gas. They are called sublimation solids. They are undergo sublimation. That is when the any elements solid phase is directly convert to gaseous phase. That is called sublimation. and this iodine is in one of the example. So when you put the iodine in the atmosphere, it forms a vapors. So that is the iodine in air is a mixture of solid in gas. Then next type is, now let us take liquid as a solute and solvent also solute. Ethanol in water or milk in water, simple. Then next liquid in solid, that is mercury in a silver, that is called as an amalgam. Then liquid in gas, that is chloroform in nitrogen. Okay, that is where liquid is a solute and solvent is a gas, that is chloroform in a nitrogen. So chloroform is a liquid and nitrogen is a gas. Now next is a gas in liquid, where gas is a solute and liquid is a solvent. Example, carbonated water. I think this carbonated water, all of it is familiar. All of you are very familiar with Layer, Pepsi, Coca-Cola, Thumbs Up, all that. What is that? It is that. But don't write this in example, in exam, that Layer, Pepsi. No. So you have, what you have to write? You have to write carbonated water. Because what we do basically in that, we take the any other solution of any juice, and in that we mix with water, and in which we mix the gas, that is CO2. So that's why that carbonated water is a mixture of solute, that is gas, and solvent is a liquid, that is carbonated water. Then next, gas in solid. Now gas in solid, in this the solute is gas and solvent is the solid, and that is H2 in palladium. This is something we use in a hydrogenation of oil to prepare a ghee or dalda. That is a vanaspati ghee or dalda. For this we use it. Then finally, mixture of gas in gas. So what is the example is, there are so many, but very common example is air. The air is a mixture of several gases, as we know it. Okay. Now shall we go further? Okay. So now let us see about the effect of various parameter on the solubility factor of a solute in a solvent. Now we are going to see about the factors affecting the solubility. Just now we saw the different types of solutions, solute, solvent. Now we have to see the factors which affect the solubility. First one is the nature of solute and solvent. It is always says that likes dissolve like. That means polar solute get easily soluble in polar solvent. Example, if you take the NaCl, that is common salt. If you put it in water and stir it, it get easily dissolved, because both are ionic in nature. Now what is the ionic in nature? That is, when we say sodium chloride, how sodium chloride is formed? The sodium atomic number 11, that is 281. Then the chlorine atomic number 30, or you can say 17. So that is 287. So sodium has to give one electron and chlorine has to accept. So the sodium donate the electron to form Na plus, while chlorine accept the electron to form Cl minus. Then both get the stable octet form, but both have the opposite charge. That one has Na plus and another has Cl minus. They attract each other to form sodium chloride. So that is ionic form. So when they get dissolved in water, that is Na plus is being covered by or gathered by the OH minus, and Cl minus is covered by the H plus. So that way they get separated. That's why the what we say like dissolve like. So that is all the inorganic solute are highly soluble in water. But if you say same this the same inorganic sources, simple common salt in acetone or the other organic, it will not, because acetone is a organic compound and they form the covalent bond. So covalent bond, they are not in ionic form. So they are so in acetone salt cannot be dissolved. So that's why we say nature of the solute, that is solute in solvent. And both should have like type. Say for example, another is the if you try to mix with the say alcohol and acid, it gets easily mixed because both are the similar mixture. Now you must be aware of that the whenever I mean normally nail polish is applied to your nail, then how it is removed? They said the remover. What is that remover? That is acetone. Nail polish is an organic material, organic compound, and we use for the that nail paint remover, that is a acetone. That is like dissolve like. Similarly, very acetone get dissolved in another alcohol. Various types of alcohol phenol that can get mixed. So the two different types of organic liquids get dissolved in each other. So that is the nature of the solute and solvent. That is first type. Then next is the temperature. Now, as we know, whenever we say the types of reactions, there are again two types of reaction which is also based on the temperature. They get divided. One is exothermic and second is the endothermic. So what is exothermic? Exothermic reaction is the reaction in which heat is evolved or heat is generated, while the endothermic reactions are those reactions in which heat is absorbed. So normally our common nature is that if you try to heat the solution, then more will dissolve. That is for common reaction is okay, but for if you consider the detailed reaction on the basis of exothermic and endothermic, exothermic reactions are not favored by rise in temperature. As the temperature rises, the solubility decreases. While in case of the endothermic reactions, the rise in temperature is favored. So that is the temperature. Now next thing is the pressure. Actually pressure doesn't have to play any role as a for example, but that something is more effective in case of the gas. If you apply the pressure to the gas, will get more and more dissolved, and that's something again I will compare to the same example like carbonated water. When you open the that cork, that gas get immediately out of it because the gas is filled in under pressure. So under pressure only gas get more solubility. Otherwise, rest of it is irrespective of that. Now, after coming to that, comparing to that, we see that next there is a very important law about the solubility, Henry's law. What is the solubility of gas is directly proportional to the pressure of a given solution. That's what I said. More you press it, more. Another example, I mean, you should give me it. Have you ever been gone to the kitchen? Yes, then you should give an example of that. What is that? The Persian gas that you use, what is that? Gas is filled under pressure, so it gets turned to liquid. As soon as you open the knob, it converts to gas, because when you open the knob, that you reduce the pressure, so that way it converts to gas. So that is another example of gas. As you increase the pressure, it converts to liquid. So that's something all about. Thank you. Now we will see in next part in the next lecture. Thank you.